All right, we have started Chapter 2, so congratulations on finishing Chapter 1. We are going to begin studying conditional statements. And in the yellow box I have written, and I expect everything that's on this video to be in your whisk. In the yellow box I have written that when we define and explain things in geometry, we use declarative sentences that can be defined as either true or false. An example would be perpendicular lines intersect at a 90-degree angle. In the next few lessons here in Chapter 2, we will look at logic statements. Logic is the general study of systems of conditional statements. So over here in the blue box, I have written if-then statements are conditional statements. Here's a very popular one. If you are not completely satisfied, then your money will be refunded. The if part is the hypothesis. The then part is the conclusion. In the green box here below, I have written another one. If today is the first day of fall, then the month is September. The hypothesis is today is the first day of fall. The conclusion is the month is September. If we look at something like this in terms of algebra, in red I have written if y take away 3 equals 5, then y equals 8. The hypothesis part is if y take away 3 equals 5. The conclusion part is then y equals 8. So you might be asked to write a conditional statement. So here in blue, I've written a sentence. A rectangle has 4 angles. When you change that into a conditional statement, it needs to have if-then. So if a figure is a rectangle, then it has 4 angles. Now, conditionals down here in the yellow box can have a truth value of either true or false. True means that every time the hypothesis is true, the conclusion is also true. False means if you can find one counterexample for which the hypothesis is true and the conclusion is false. So I've given an example of this in red. If it is February, then there are only 21 days in the month. But I've proven this false because I know that this past February, 2016, had 29 days. So this had a false value. Sometimes we can use Venn diagrams to help illustrate conditional statements. I've included my little puppies here. This is Spanky. He's 3. He's almost 4. And this is Sophia. She's 12 and a half. Bless her heart. She's a sweet baby. And they're so cute. Anyway, I drew this Venn diagram and put dogs in the entire part and Jack Russells in the smaller part. If something is a Jack Russell, then it is a dog. So, there's my babies. Now, the converse of a conditional switches the hypothesis and the conclusion. So I've given you an example right here. The conditional is if 2 lines intersect to form right angles, then they are perpendicular. The converse, I'm going to switch it. If 2 lines are perpendicular, then they intersect to form right angles. And I wrote out beside here that both of these are true. The conditional is true and its converse is true. Sometimes that doesn't happen, such as in this example. These have different truth values. The conditional statement is if a figure is a square, then it has 4 sides. That is true. The converse, if we switch the hypothesis and conclusion around, If a figure has 4 sides, then it is a square. That is false. And my counterexample is a rectangle. So we are going to work next couple of days on conditional statements. And yes, I'm going to repeat this one more time. I do expect to see all of this information in your whisk. And I'll leave it right there at my babies. Thank you very much.